All right, so in this video, we're going to be taking a look at different ways to take data and organize it into a frequency table, and then let that data be represented into a nice histogram so it's more visually appealing to your audience. So first, let's just take care of some vocab. We have that a frequency table is what's going to list each data item together with the number of times something occurs. So in this first frequency table, we have a teacher and the scores of the different students on a test that she gave. And it looks like here, for example, we can see that 5 of her students scored somewhere between a 71 and a 75, all right? So what the frequency table does is it shows the number of times something occurs. And right here, we can see the number of students that fell into each category. Now, a histogram is a lot like a bar graph, except the categories are numerical. And I want to remind you guys that numerical, it means quantitative, okay? Real quick, let me remind you guys about a bar graph from elementary school. So a bar graph shows qualitative data, categories like purple, red, yellow, green, orange. Those are words, and we have spaces in between the bars because these categories don't necessarily run together. Now, something that this graph has in common with a histogram is that the height shows frequency. And so how tall the bar is lets you know how many are in each category, and that's something that's similar with the histogram. Now here with the histogram, what we do is we take the data and we organize it into equal intervals. So for example, 71, 72, 73, 74, 75, that's 5 possible scores in this category. And if you count again, 76, 77, 78, 79, 80, we have 5 more scores. So these intervals are all equal. And once again, the height of these bars will show the frequency or the number in each category. Now, a key thing here is that there's no spaces in between the bars because we're now using numerical data, quantitative data, and there's no space between the 75 and the 76. You are either in this category or right on into the next one, okay? So now let me just walk you guys through this example. If you're given this frequency table, all we're saying is that in this interval of 71 to 75, 5 people scored between 71 and 75, and there's the 5 people right there, okay? Now, in the next category from a score of 76 to 80, it looks like 4 of her students scored there, and there is the 4 students. Now, the good news for this teacher is that the majority of her students, there's 9 students right there that fell into this category. So we have 9 students who scored an A+ on the test. And if you add together the 91 and 95, we can see that 16 students total are in that category. So it looks like overall the teacher can think that, okay, a lot of her kids did really, really well. Okay? All right, now let's answer this series of questions based on either the frequency table or the histogram. So for the first question, we just want to give an example of one of the intervals. So I just picked randomly, I picked the 86 to 90. Okay, so let me just erase all this stuff real quick. And I'm randomly just picking this interval to give as an example. Now, in that interval, it looks like 4 students scored between an 86 and a 90. So what is the frequency of that interval? 4. And what does that mean? That means that 4 people in the class scored between an 86 and a 90. Now the next question asks, what's the lowest score that somebody got on this math test? Now we don't actually have the list of scores in front of us. We have no way of knowing at all, out of these 5 kids, I don't know if those 5 kids all got 76s. I don't know if there was a 72, a 72, a 73, a 74, and a 75. We have no way of knowing what these 5 kids actually got. We just know that they scored somewhere between 71 and 76. So for that reason, we cannot tell the lowest score. Similarly, we cannot tell the highest score because we have no way of knowing what these 9 kids actually got. We just know that they got somewhere between a 96 and 100. Now, some of you might be thinking, well, if 100 is listed here, it has to be the biggest score. Well, not necessarily. Remember that the intervals have to be equal intervals. So these are just going by 5s no matter what. And it's not necessarily saying that we have a 71 and 100 in the data set, okay? All right, now we're moving on, and now let's take a look at question 4. So for question 4, it asks, how many students scored less than an 86%? So let's look, and we can find the answer in both places. So less than an 86 is going to be above that red line. Less than an 86 is going to be below this red line. So we're basically going to add 5 plus 4 plus 8. We're going to add this 5 plus this 4 plus this 8. And that's going to be all of the kids who scored below an 86. And when you add these up, we get 17 students right there. Now for the next one, it's asking how many students scored more than a 90. So more than a 90 is going to be below this blue line, and more than a 90 is above right here. So we've got these 7 plus these 9, and here's the 7 plus the 9, and that's where I got this 16. Okay? All right, let me just erase that. Moving right along. So now we're on number 6. How many more students scored between a 71 and 80 than who scored an 81 to an 85? So first, let's focus on the 71 to 80 range. Okay, 71 to 80. Let me get rid of that real quick, sorry. All right, so for 71 to 80 up here, 71 to 75, and then we'll also include here. So we have 9 students who scored between a 71 and an 80. That's where I got this 9 from. Now, the 81 to 85 right here, that's 8 students. So how many more students did we have in this category than this one? We just had 1 more student. All right? Cool. All right, now let's take a look at question 7. It asks, which interval contains 5 more scores than the interval of 86 to 90? So 86 to 90, we have 4 people who scored there. Now, which interval has 5 more kids than that? 4 plus 5 is 9. And that's how I got the 96 to 100 interval. Okay? All we're saying there is that there's 5 more kids in this category than there were in this category. All right? We're almost done here. Now we're on question 8. So how many students scored between an 81 and a 90? Now this is a tough question, but it's actually really easy once you know where to look. So between an 81 and a 90, let's go back up to the chart. Between an 81 and a 90, right here and here, we have 12 students. On the frequency table, we found the answer there, and on the histogram, 81 to 90 is going to be this bar and this bar. So it's going to be these 8 plus these 4. Now, y'all, what's 8 plus 4? 8 plus 4 is 12. So we have 12 kids who scored in this category. Now, the other thing we need to know is how many total kids were in Miss McGrath's class, okay? So it's okay if you want to use your calculator for this, but we have the 5 plus the 4 plus the 8 plus the 4 plus 7 kids plus 9 more kids. It looks like we have 37 kids total, okay? Now the question only asks how many students scored 81 to 90, and that's just adding up the 8 to 4, which is easy. What I do want to point out is that we can take this a step further if the question says what percent of students scored between 81 to 90, and that's the part that I was mentioning was going to be a little bit tricky. But if we know that we have 12 kids who are in that category out of 37 kids who took the test, we can figure out what percent would be in that category by just dividing, and we could say that that's about 32% of the kids, okay? Cool. And now for the last one, it asks how many fewer students scored between a 71 to 80 than a 91 to 100. So let's take a look. So from 71 to 80 up here, let's just erase real quick. 71 to 80 was these 9. And then we're comparing to the 91 to 100 range. So 91 to 100 is going to be these 16. So we only have 9 kids in that group, and we have 16 here, and that's a difference of 7 kids. There were 7 fewer kids in this category than were in this category. And that's a good thing. The goal is to be able to see, okay, in the CB, like in the, this would just be the C range actually, just as just the C's. So we can see we've got 9 C's, but then we have 16 A's. So the teacher can be like, all right, if I have 9 C's, 12 things that would be in the B range, and then 16 things that would be in the A range, I think this teacher can assume that they did a pretty good job teaching everything, because we can see that 28 kids got either an A or a B, and that's really, really good. Okay? Now we're going to flip over, and now with this next one, I want to point out that the difference here is that we actually have our data set. Now it's going to be really tempting to just go ahead and put these numbers in the stem and leaf plot, but just chill real quick and take a look. We were actually given here all of the numbers in the data set. So we can look and see what the smallest number is, and we can look and see what the biggest number is here. For this example, we didn't have the scores of Miss McGrath's class, so we were not able to answer the questions down here, 2 and 3, that asked what's the lowest and the highest score. Now with this next example, we do actually have the data, so we might be able to answer questions like that. Now let's talk about what we're looking at. We're looking at the ages of people who attended the last town council meeting, and they're shown below. Now, one of the skills that you're going to have to develop is to take the data and organize it into this stem and leaf plot. Let me just remind you guys what a stem and leaf plot is. The stem stands for like the tens, so this would be the 30s, 40s, 50s, 60s, and 70s. And then over here, it'd be the ones. So we have somebody who's 31, then a 32, then a 36, and then a 38. Now you can already see that I've got the slash marks through the numbers, and that's because I already took the data and organized it here. But in red, I'm just going to kind of model what I did. I went after anything in the 30s. So up here, I saw that I had a 36, a 38, a 31, and a 32. And then I just wrote those numbers there from least to greatest, and I just slashed out along the way as I went through. Now I checked in the end to see if I had all my numbers by simply counting. I just went through and said, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got all of the numbers in my stem and leaf plot. Now you can use either the list or the stem and leaf plot to tally up the ages that fall into these different intervals. So for example, if I look at the stem and leaf plot, the ages of people who are 31 to 40, I tally 1, 2, 3, 4. There's my 4. Now it matches up for the most part, but I do want to draw your attention very carefully right here to where the 61 starts. 61 to 70 over here, I have 1, 2, 3, 4 numbers. This is a 70, and even though it gets its own category in the stem and leaf plot, it fell into the 61 to 70 category right there. And then you can see in green that I'm going to have only 3 71 to 80 year olds, and it's 71, 72, and 75. Now let's take a look at the table. Now you're going to see this in some of the frequency table examples, something called cumulative frequency. And cumulative frequency is generally the last category in one of these frequency tables. And I'm going to actually just draw it in for you guys to show you how it works. It's the easiest thing in the world. The cumulative frequency just adds it up along the way. All right, cumulative frequency. So for example, in this category so far, only 4 ages or 4 people's ages have been considered. Now when we consider the next group of data, we've got this 4 plus 3, so 7 people have been tallied. Now 7 plus these 6, we've got 13 people's ages so far. 13 plus 4 is 17 people's ages so far. And 17 plus this last 3, that'll tell you the total number of people that you have in your data set right there. That's going to be the total number in your data set. What cumulative means is that it just kind of builds up, it accumulates, so it just continues to add and build up along the way, and then right there it gives you the final frequency. All right, now I've already got the frequency table moved into a histogram for you. You have a blank graph, and I'm just going to suggest that you count every 1, 2, 3 bars and kind of draw a little line here for yourself. All right, and all I did was take the intervals from up here, the 1, 2, 3, 4, 5 categories, and listed them here. And then I just labeled this axis the age in years. And then the height, again, a height will always show the frequency. So that first category, it's a 4. So notice it has a height of 4 right here. The second one, we had 3 ages, 3 people who had ages 41 to 50 who attended the town council meeting. Then here, the height was a 6, then it went to a 4, and then it went back down to a 3. Now think about a town council meeting, y'all. Town council meetings are about what's going on in the city, what's going on in the town, and the people who care about this, who are actually able to go, I feel like this kind of reflects that. Right here, you might have people who are parents, okay? This is generally the age of people who have somebody who's either a baby or all the way up to high school. But right around here is when you start to see people who, they might not have any more kids at home. And so we can see that this category is best represented at the town council meeting. Now, obviously, some elderly people are still going because they care, but I just wanted to point out here that this graph kind of makes sense for who you'd expect to see at a town council meeting. So now I'm just going to flip over here, and I have the frequency table, the histogram. I put the image next to it so that we can answer these questions together using this image. So, what is the youngest age? Now, it says, answer the following questions regarding your histogram. Now, according to the histogram, again, we have no way of knowing what the ages would be in this category or in this category for the youngest and oldest. Now, we only know this because we can see the data on the other page. We can see that the youngest person here was 31 and the oldest was 75, okay? So the only reason we can answer that question, those sets of questions, is because we have the data. If you don't have the data, it's a trick question. You can't answer it, all right? Now for number 3, it asks, what percent of the adults are less than 51 years old? So over here, I see 51. So less than 51 is going to be these 2 red categories. And I've got these 4 plus these 3, so we've got 7. Now, there were 20 people who attended, so 7 out of the 20 would be 35%, all right? Now it asks what percent of the adults are 31 to 50. That's another way of asking what we just answered. So 31 to 50 is these 2 categories, so those same 7 people, so that same 35% of the data, all right? And it would make sense that the other 65% of the data is over the age of 50 because of what we just talked about. Anybody under the age of 50 might be young enough or have kids and not be able to attend the town council meeting. But once your kids are older and they're out of the house and they're in college or whatever, that's when you can care again about having the time to go to these the town council meetings to voice your opinion for what's going on in the city. All right, now for number 5. How many more adults are from 51 to 60 than from 71 to 80? So let's talk about where I got these numbers from. So 51 to 60 is this category, and it has a height of 6. So that's where I got the 6. And then 71 to 80 is this group right here, and it has a height of 3, so that's where I got the 3. And now it's just asking how many more adults were in that age group than were in this age group, and that's where I got the 3. Okay, 6 minus 3 is 3. All right, now let's just erase that. Now we're on question 6. For question 6, so how many fewer adults are in the 71 to 80 category? So 71 to 80, that's the 3. And 31 to 40 is the 4. So there's just a difference of 1. Okay? Question 7 asks us, which interval has the same number of adults as the 41 to 50-year-olds? So 41 to 50 had 3. And then the other one that has 3 would be right there. That's the 71 to 80. They both have 3. And the last question asks us that the 61 to 70-year-old interval has 2 fewer adults than which interval? All right? So the first one it asked us about was 61 to 70. So over here, that was 4 people. That's where I got the 4. And it's asking that is 2 fewer than which one? Well, 4 is 2 fewer than the number 6. So it's asking us to identify this category, the 51 to 60-year-olds. Okay? Now for this last example right here, you can see that it does have the cumulative frequency in the chart. And what we're looking at here for this third example is a sporting goods store recorded the number of tents that it sold each week in February and then used the data to make a frequency table. So in the first week, only 5 people bought a tent. Now in the second week, 12 people bought a tent, which means there were 17 total sales as of week 2. Maybe they were unveiled at a store and only a few people saw them, and then word got around, and so then the next week, a bunch of people were there to buy the tents. Now in the third week, we can see that 7 more people bought a tent, which is 24 tents sold total. And then in the last week, on that fourth week, 10 more tents were sold, and so there were 34 tents sold total. Now what the question asks us is, what percent of all tents sold were sold during the first 2 weeks of February? Now, in the first 2 weeks of February, we have week 1 and week 2. We can add or just look at the cumulative frequency and see that it was 17 out of the entire 34 that were sold. So in the first 2 weeks of February, 50% or half of the tents were sold in the first 2 weeks, and the other half were sold in the other 2 weeks. And that information is written in here now. All right? And that concludes this video on frequency tables and histograms. Thank you.